Okay, so we know a relation can be written as a set of ordered pairs. Okay, so your ordered pair, if you remember, is just your x comma y. That's your ordered pair. Okay, now the domain of that ordered pair is just every possible x value. Okay, that's really all it means. And the range is every possible y value. Okay, so let's say, for example, if we wanted to determine the domain and range, bless you, of the relation, let's say for problem A, you have 2, 3, 2, 4, 0, -1, and 3, -1. Okay, and for B, you have the ordered pair -3, 1, -2, 1, -1, 1, 1, 1, and 2, 1. Okay, so those are just all points on an XY plane. You can plug each one of those points in and you'll have your graph. Okay, so the domain for A, remember the domain is just all your possible x values. Okay, so all the x values that appear for A, you have 2, 2, 0, and 3. Okay, so you don't have to write them down when they repeat. Well, when they repeat. So it's just 2, 0, and 3. Okay, so that's your domain. Those are all your possible x values. Okay, does that make sense? Okay. And we do the same thing for the range, which is just all your possible y values. Okay, so for your y values, you have your 3, 4, -1, -1. Remember, that's just 3, 4, and -1. Remember, if they repeat, you only have to write it down once. So you don't have to write down -1, -1. All right? And we do the same thing for B. Okay, so you notice your domain are all your possible x values. You have -3, -2, -1, 1, and 2. Okay, so what will your range be? Yep, just 1. Because even though it repeats over and over and over, it's just that one range value. So that's all you have to put down. Okay. Any questions on that one? All right. Okay, so let's say, for example, you want to figure out the domain and range, but they're not given to us as just points, but they're given to you as inputs and outputs. So let's say if you have okay, so let's say if your input and you have output. Okay, so for your input you have cities. And your output is population. All this is a fancy way of saying these are X and this is your Y. Okay, so if you have Lubbock, Texas, you have Colorado Springs. So you have Omaha. Let's say we have Sacramento. Okay, and for population, if you have, let's say in thousands, okay, so let's say if you have 370,000 here, so you have 197, you have 404,000, even you have 35,000, 445,000, 206,000, and 197,000. So all you have to do is just have your function go from one X value to one Y value. So Lubbock, we'll make that 206,000. Let's say Colorado Springs, we'll make that 370,000. Say for Omaha, we'll make that 404. And for Sacramento, we'll make that 445,000. Okay. Now for this one, your domain is just everything listed in your input or your X values. Yep, make sure I have that. So your domain will be Lubbock, Colorado Springs, Omaha, and Sacramento. And go ahead and close that up. Now your range is every possible Y value. But the thing is just the Y values that were picked. So our population, our range, even though we didn't pick every Y value, we had more possible Y values. So that would be 370,000, 197, 404, 35, 445, 206, and 197. Okay. Now, just because those are possible values doesn't mean we're going to pick every one of them. So our relations are just the ones that match up. Okay. So it's just your ordered pair. We know that Lubbock is paired with 206,000. We know that Colorado Springs is paired with 370,000. Okay, we know that Omaha is paired with 404,000. And we know that Sacramento is paired with 445,000. Okay, so you have your domain, your range, and your actual ordered pair. Okay, so you'll see it in kind of different ways. You can see maybe a list of cars and colors, and then you'll see them matched up both ways. So it can be listed either way. All right, any questions on that one? Okay. Okay, so now we're going to go into the definition of a function. Okay, now a function is where your first component, which is your x value, is paired to exactly one y component, or a second component, which is your y value. Okay, so you have a function is a relation in which each first component of an ordered pair corresponds to exactly one. Uh-oh. And it's that exactly one. That's important. Second component. Okay. So when we put out our list of ordered pairs, you'll see why that exactly one is really worth remembering. Okay, so let's say, for example, determine if the relation is a function. Okay, so let's say for A, you have -2, 5, 2, 7, -3, 5, and the ordered pair 9, 9. And let's say for B, if we have -4, 2, -3, 8, say 7, 8. If we have, let's say, 4, 2. And let's say for problem C, if we have, let's say, -1, 4, make this 0, 5. Let's say if we have -1, 3, and if we have 2, 0. Well, those are supposed to be little brackets. There we go. Okay, so we have to figure out one by one whether they represent a function or not. Okay. Now for the first one, do you think that's a function or not? Yep, actually, that one is a function. Only because, if you notice, the -2 here, -2 only has one value. 2 only has one value. -3 only has one value. 9 only has one value. You don't see -2 having a different value somewhere else. So as long as each x value has exactly one y value, then it's a function. So A is a function since every x value has one y value, or has exactly one y value. Any questions on that one? Okay, so let's try B. -4 only has one value. You don't see -4 equaling anything else. -3 has one value, so you don't see it equaling anything else. 7 only has one value. You don't see it equaling anything else. Same with 4. +4 only has one value. Now, if you notice, each x value can only have one y value. But if you notice, the y values can be the same. You can have the same y value, but that doesn't matter because it's only important if each x value has one y value. You could have had all of these have 8 in the y values, and it's still a function. So it only has to match up that way with the x values. Does that make sense? All right. So we know that for B, it is a function. Again, since every x value has exactly one y value. Okay. Now, if you notice with C, for this ordered pair, -1 is equal to 4. But for this one, -1 is equal to 3. That automatically lets you know it's not a function because each x value can only have one y value. Okay, so it's not a function. So clean that up a little bit. Since x equals -1 has y equals 4 and y equals 3. Okay, so it can only have one. So each x can only have one y. Okay, any questions on that one? All right. Okay, so let's say if we try this one. This is the third page. Determine if the relation, sorry about that, is a function. All right, so for the first one, we'll say y equals 3x minus 5. And let's say for B, x equals y squared. Okay, so for A, if you plug in x equals 0, you'll get a certain y value. You plug in x equals 1, you get a certain y value. You plug in x equals anything at all, you'll only get one y value for each number. Even if you plug in a decimal number, you'll only get one. So whenever you can plug in an x value and get a different y value each time, then you know you have a function. Because remember, each x can only have one y answer. So this is actually a function. Every x has one y. Okay. Now, if you look at B, that one's a little bit different. And I'll show you why that one's different. So if we let x equal 4. Okay. So if we let x equal 4, that means that only one value of y should equal 4. I mean, on one value from x should be plugged in when you replace it with a y to give you a 4. The only problem here is more than one value of y would make that true. So that means x would actually have two values. So when x equals 4, y equals 2. That means, well, where's out here though? 2 times 2 is 4, which is true. So you have a 2 there that would make that true. The only problem is when x equals 4, y can also equal -2. Because -2 times -2 is positive 4. So here, you have a positive 4, but you also have a -2. So you have an x value with 2 different y values. So that's why that one wouldn't be a function. And a quick hint, whenever you see y squared, y to the 4th, y to the 6th, any even exponent, you know automatically it's not a function. So you don't even have to go through that. Whenever you see a y squared anywhere in there, it's automatically not a function. So it's not a function since, so make sure it's on up. The x value has more than one y value. Okay, so they kind of show up in different ways. Okay, any questions on that one? All right. Oops. Okay, so now we're going to do the vertical line test, which, if you remember, the vertical line test is the easiest way to figure out if a picture of or image of a graph is a function or not. So make sure. Okay, so just the vertical line test. Okay, so if no vertical line can be drawn, so that it intersects a graph more than once, the graph is a function. Okay. If it does intersect the graph more than once when you draw a vertical line, then it's not a function. Intersected more than once. Uh-oh. For any single vertical line. Then it is not a function. Okay, so the actual description of it is a lot more complicated than performing the vertical line test. So let's say, for example, let's say if we have our x-axis and our y-axis here, and we draw our line. This is our f of x right there. So if you have, oh, where's my pen? Thought I had it up here. Nope, guess I don't. Oh, here we go. Okay, so if you get a vertical line anywhere on that graph, so we draw a vertical line here, 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 here. If you notice, no matter where you draw a vertical line, it only intersects that one once. You draw a vertical line here, it only crosses that graph once. No matter where, each vertical line only crosses that graph once. So you know that this one is a function. It's only not a function if it crosses more than once. Okay, so let's say if we have the x-axis here, the y-axis here, and let's say if this is just y is equal to 5. Remember, y is equal to anything is just a horizontal line. Okay? So we do the same thing. We just draw a bunch of straight lines to make sure it doesn't cross more than once. So if we draw all of our straight lines, we notice no matter where we draw a straight line, it only crosses that graph one time. So you know that this one is a function. Okay. Any questions on that one? All right. Okay, so let's say, make sure I go up far enough. If you have the graph, I'll just put a good old-fashioned circle. Okay, just a graph of a circle. Plain, ordinary, basic circle. Okay. Thing is, no matter where we draw a vertical line, we can only draw one, because it only takes once to declare it not a function. We see this vertical line crosses this graph here and here. Okay, so whenever you cross a graph more than once with the same vertical line, not a function. Okay, so let's say if we have our x-axis and our y-axis here, and let's say if our graph is x is equal to 4. We know x is equal to any constant, it's just a vertical line. Okay. You think that's a function or not? Nope, not a function. Because if you draw a vertical line right through it, it's going to cross more than once. Okay. So that means it's not a function. Okay. Any questions on that one? All right. Okay. So now, let me do one more example because this is the one we just did. If you notice before, when we had our x equals y squared, that has the graph that looks like that. So that's how x equals y squared would look. So if we knew what the graph looked like before we saw the equation, we can look and say, okay, vertical line test, that one line crosses there and there. So we know it's not a function. So we didn't have to figure it out that way. We could have just looked at the graph and saw it wasn't a function. Okay, so any questions on that one? All right. Okay, so we're going to do a quick review of function notation, which most of you may remember. If not, we're going to go over it real quick. Okay. Function notation is just changing y equals, let's say, 3x plus 2. We will let y equals f of x, which is just another way of saying function of x. Okay, so once we have our function